Hello, this presentation is for project 2 for our class web analytics. The goal of this project was to analyze the neural networks of the elegance worms using social network analysis techniques. The elegant worm has been extensively studied and is known for its relatively small but well characterized nervous system, which consists of 302 neurons. To begin with the analysis, with the code, we imported the necessary libraries and retrieved the dataset containing information about the neural network from a given URL, as you can see here. Also, there is a hyperlink in here to go and check the dataset. And the dataset consisted of 306 nodes representing neurons, and the connections between neurons were represented as edges. So after obtaining the dataset, we process the data by splitting it into columns and dropping the unnecessary columns. This step helps us to focus on the relevant information for analysis, namely neurons and edges. So to gain some visual understanding of a network, we proceed to create subgraph for two distinct groups, and we call it N1 and N2. So the subgraph allow us to focus on a smaller portion of the network and analyze them separately. To create this graph, we use the island method, which is we're gonna see here. Using the island method. Okay. Excellent. So which this method involves interactively removing edges below a certain weight threshold to identify a smaller connected subgraph within the larger network. By trimming the edges based on our weight, we were able to reduce the size of the network and focus on manageable portions. We can appreciate the subgraph in here a little bit up. Yeah, so for each subgraph and then N1 and N2, we experimented with various weight thresholds and observe the resulting number of nodes in each subgraph. This analysis helped us to identify distinct groups within the larger network. And by examining these different values, we gain some insights into the structure and organization of the network. And additional to this, we explore the centrality measures of the networks, as we can see a little bit down. Yep. You can see some graphing here too. Yeah, so the centrality measures help us to understand the relative importance of nodes in a network. We analyze three centrality measures: degree centrality, closeness centrality, and betweenness centrality. Degree centrality measures the number of connections a node has, while closeness centrality measures how quickly a node can reach other nodes in the network. So betweenness centrality quantifies the extent to which a node lies on the shortest path between other nodes. And by calculating the centrality measures for each node and the neighbor one, we were able to rank the nodes based on the importance. This provided value insights into the key nodes within the network. And furthermore, we also apply the community detection to both networks, N1 and N2. And the Rubine algorithm is popular community detection that assigns nodes to different communities based on their connections. And by detecting these communities, we aim to uncover the underlying structure of the networks and identify groups of nodes that um, interact more closely with each other. This analysis allowed us to gain some insights into the functional organization of the neural network. And we have here some graph and the same measures to the other net. And also a graph. Well, in summary, this project involved analyzing the neural network of the elegant worms using the social network analysis techniques that we have been seeing by creating subgraph, applying the Hanna method, and experimenting with different weight measures. We identify distinct groups within the network. We also analyze centrality measures to determine important nodes in the network and utilize the I think it's called Luban community detection to uncover communities. These findings contribute to a better understanding of a complex neural network of this data set. And well, as a conclusion, overall the network appears to have some highly connected nodes with a relatively high degree centrality and closeness. However, the absence of non-zero between the centrality values indicates that there might not be significant bottlenecks of nodes that play a crucial role in the flow of information or influence within the network, as we can appreciate in the last graph. And thank you so much for watching this video for our project 2.